On behalf of the planning team that includes representatives from the U.S. Department of Agriculture, Natural Resources Conservation Service, the Georgia Soil and Water Conservation Commission, the Upper Chattahoochee River Soil and Water Conservation District, and Schnabel Engineering, we'd like to thank you for your interest in the planning study that is currently ongoing for Settingdown Creek Dam number 59. This is the second public meeting that is being held as part of the planning process for this dam. The purpose of the planning studies that are being performed for the Settingdown Creek dams, including dam number 59, includes the assessment of the Settingdown Creek Dam number 59 watershed, an evaluation of the performance of the existing watershed structure, development of plans to address compliance issues with the current dam, and to determine if federal financial assistance will be available to address compliance issues. Also, if the project sponsor would like to continue operating the dam within the current NRCS watershed program. As part of the planning study, a public participation plan is required to support the planning effort. The objective is to inform the public and watershed stakeholders of the planning effort. The planning study requires a series of public meetings. The first public meeting presentation included a brief history of the National Resources Conservation Service watershed program, a brief history of dam safety, considerations for dam design, operation, and maintenance, an overview of the Settingdown Creek watershed, and specific dams that are included in this study, and also the solicitation of questions and comments based on scoping topics and the identification of project opportunities and concerns. This initial presentation was provided in August of 2020, but please note that the initial public meeting presentation is also being reposted to Schnabel's YouTube channel to run concurrently with these second public meeting presentations. They will be available until early January for reviewing and comment. This is the second presentation for this particular dam, and in this presentation we will discuss the following topics: an overview of the Settingdown Creek watershed, the existing conditions associated with Settingdown Creek Dam number 59, and a discussion of rehabilitation alternatives under consideration for the dam. At the end of the presentation, there will be an opportunity to click on a link or input a link to get to a Google form where questions and comments can be submitted by interested parties regarding the planning study for this dam. Just a brief overview about the Settingdown Creek watershed. It is located in northern Forsyth County, Georgia. Settingdown Creek is a tributary of the Etowah River, which flows into the Coosa River near Rome, Georgia. The Settingdown Creek watershed contains over 34,000 acres of drainage area. The original watershed work plan, prepared in April 1954, provided for the construction of 15 floodwater retarding structures, also known as the Settingdown Creek dams. This study includes 6 of those structures, and this presentation focuses specifically on dam number 59. This is aerial photography with the limits of the Settingdown Creek watershed shown in red. As you can see, there's some project area features, including US 19 or Georgia 400 that's noted near the right side of the view. Also, Keith Bridge Road, Dahlonega Highway, Matt Highway, all major roadways in northern Forsyth to provide context at where the Settingdown Creek watershed and dams are located. Here's a photo taken in the early 1960s that includes aerial photography of the watershed prior to the development and construction of many of the dams that are included in the watershed. There's been a tremendous amount of residential and commercial development within the watershed since the early 60s, and that's part of the reason for studying these dams and assessing whether or not they're in compliance with current dam safety regulations. As a reminder from the initial public meeting, the focal points of this analysis and study associated with the watershed are an analysis of the upstream areas, including flooding and additional storage capacity, evaluation of downstream areas for flooding associated with frequency storm events, as well as the breach zone were the dam to fail catastrophically. Also, the hydraulic capacity of the existing spillway outlet works was assessed, and for various storm events, including large storm events that are required by both the state of Georgia and the federal government. The study will also include an evaluation of the economic and social benefits the dam currently provides, also an environmental assessment to identify potential species of note, wetlands and/or jurisdictional waters in the vicinity of the dams that would need to be considered during any rehabilitation. And finally, a cultural resources study has been performed to determine whether or not there are any items of historical significance associated with the dams prior to any rehabilitation. This map shows the Settingdown Creek watershed again with the 6 dams that are included in the current study. Specifically talking about Settingdown Creek Dam number 59, the dam meets Georgia Safe Dam Program criteria to be considered a Category 1 high hazard dam. This means that failure or improper operation of the dam would likely result in the loss of human life. The dam needs an operating permit from the SDP and currently does not have one. Previous assessments of this dam indicate that the dam does not comply with current SDP rules and regulations. The dam is not exempt from these rules and regulations. A purpose of the planning study is to determine if federal assistance will be available to bring the dam into compliance with current dam safety requirements. The Georgia Safe Dams Program is fully aware of this dam, its classification or pending classification as a high hazard dam, and that the dam is being studied by the planning team. Some original design features for dam number 59 include that it was not originally designed as a high hazard dam. The purpose of the dam was originally flood mitigation, and an anticipated secondary purpose of the dam was sediment accumulation and storage. The dam was originally designed and constructed with a reinforced concrete principal spillway, which consists of a riser structure that's in the lake and a pipe or conduit through the earthen embankment to convey water from the lake downstream to the outlet channel or creek. The dam also includes a vegetated earthen auxiliary spillway or emergency spillway channel that would flow in the event of increased flows into the dam, so that water would go around the dam and not over the dam, which could lead to its failure. Once again, we're looking at a map of the Settingdown Creek watershed, and the location of dam number 59 is highlighted in yellow. It is the most upstream dam in the Settingdown Creek watershed, the furthest to the east on the map shown. Settingdown Creek Dam number 59 is located adjacent to the Hampton Golf Club, south of Glen Haven Drive. It was built in 1954, which makes it approximately 66 years old. The dam is currently 33 feet tall, with a drainage area of just about 1.8 square miles. The design storage capacity of the dam was 586 acre-feet, and that includes considerations for sediment accumulation, flood control, and surcharge above the auxiliary spillway. Here's a 1956 aerial photo taken recently after the construction of the dam. As you can see, there's not much development. The golf course has not been constructed, nor the residential communities surrounding the lake. Here's a more recent aerial photo that's taken that does show you portions of the golf course and residential development around the lake. Also of note is the existence of a water treatment center just to the south of the dam. The dam does have a cart path associated with the golf course that traverses the crest of the dam and allows for crossing of the creek and lake from one side to the other. This is an aerial photo taken to support a survey that was performed this past 2020 of the dam. You'll note that the dam was recently cleared prior to this photo, and the light brown or yellow areas on the embankment are places where straw and erosion control matting have been placed over the disturbed ground that resulted from the clearing of the dam. The dam previously was covered in trees and other inappropriate vegetation, and the sponsoring local organization arranged to have the dam cleared in advance of these studies. As you can see, the lake is at the bottom of the screen. Typically with dam engineering, this is the orientation of a dam that we typically follow. So as we move forward, you'll note that some of the maps with respect to the dam include the lake at the bottom with flow going up toward the top of the page. So upstream would be in the downward direction, and downstream would be at the top of the page in these cases. This is a site plan using GIS topographic contour information. As you can see, as described, the location of the principal spillway, as well as the concrete path along the top of the dam. The water treatment facility is located to the left of this view, and you can see several residential properties located along the right side of this view. The auxiliary spillway that was discussed is located near the right side of this view, and there's a general alignment of that spillway channel shown on the right side of this page. Here's a photograph that was taken a few months ago of the dam after it's been cleared and the grass is reestablished. You can see in the background the residential homes. You can also see the concrete riser structure, the crest of the dam, which has the golf cart path going across it, and the upstream slope. There's also a dock that's been constructed on the upstream slope of the dam. Here's a photo from the crest of the dam looking downstream. The grass areas kind of in the foreground of the photograph are the downstream slope of the dam. You can see the concrete pipe that goes through the embankment and discharges into the outlet channel, which is lined with riprap at the downstream end of the dam. The principal spillway conduit is indicated along with the plunge pool where water discharges and the downstream slope. As part of the planning study, an environmental survey has been performed for the dam and adjacent areas. During this survey, no protected species were identified. Some invasive species, predominantly Chinese privet, which is a vegetative species, were identified as indicated on the aquatic resource survey map shown on this slide. Also, a Phase 1 cultural resources survey was performed for dam number 59. The survey included a literature review as well as field activities and shovel tests. No archaeological resources were recorded on this site. The dam, being in the range of 57 to 64 years old, is really the only historic resource, but it is not eligible for the National Registry of Historic Places. No additional cultural resource work has been recommended by the team that performed the cultural resources survey for this dam. Here is a breach inundation map and identification of downstream hazards. As indicated previously, this dam does meet the requirements as a Category 1 or high hazard dam, which means that if the dam were to fail, that loss of life would be imminent or likely. The dam breach inundation limits shown on this map were derived based on a sunny day breach with the water surface at the top of the dam, which is a common and required configuration for a dam breach for both the Georgia Safe Dams program as well as the NRCS. This is a downstream flood analysis map that was developed by Schnabel. This particular map includes consideration for all areas within the Settingdown Creek watershed upstream of John Burris Road. The limits shown on this map indicate areas that would be flooded during both the 100-year and 500-year 24-hour storm events. Downstream flood analysis is an important part of the planning study as it allows the planning team to identify and quantify the benefits that are provided by the existing dam. This map indicates the upstream flood limits of the lake. Several storm events have been run through the lake and spillway outlet works, and in doing so, the planning team has been able to identify the water surface elevations associated with those events. As you can see on the left side of this view, there's a legend that indicates the normal pool elevation of the lake, the elevations associated with the auxiliary spillway and dam crest, and also the storm event elevations, the water surface elevations associated with several storm events, including the 100-year storm, the 500-year storm, the Safe Dam Program Design Storm, which is currently the 1/3 probable maximum precipitation storm event, and the Freeboard Hydrograph Storm, which is the NRCS Design Storm event. The FBH, or Freeboard Hydrograph, represents 100% of the probable maximum precipitation in this area, which is generally around 30 to 32 inches of rain in a 6-hour period. Existing dam deficiencies. The dam was recently cleared during the summer of 2012. Previously, there was a lot of inappropriate vegetation and trees growing on the dam, and those trees and vegetation have since been removed, and the ground has been re-stabilized with an appropriate turf grass. An underwater inspection of the riser structure by commercial divers concluded that portions of the slide gate assembly associated with the riser structure are worn and or corroded. Portions of the riser concrete are cracked and or spalled, which is not surprising given the age of the structure, and a closed circuit television camera inspection of the principal spillway conduit is scheduled to be performed, and we are awaiting the results of that inspection. Existing hydraulic deficiencies with the dam. Based on Georgia Safe Dams Program criteria, the dam overtops by 1 foot during the design storm, which is not good, and also the auxiliary spillway breaches, which means that there would be a significant amount of flow, enough to where the earth spillway would erode to the point that the entire dam would fail. The NRCS criteria that were assessed, the auxiliary spillway engages prior to the PSH storm event, which is the principal spillway hydrograph storm event. The principal spillway conduit is incapable of meeting the PSH drawdown requirement, and the auxiliary spillway is about 4.3 feet lower than required by NRCS requirements. During the NRCS design storm event, which is 100% of the PMP, the dam overtops by 4.3 feet and the auxiliary spillway breaches. So in order to meet the compliance or address the compliance issues with the dam, the planning team has worked up several rehabilitation alternatives for consideration. The majority of the alternatives will be based on federal criteria, although we have looked at rehabilitating the dam to meet state criteria, which are a little less stringent than federal criteria. So the future without project or no action alternative would be instituted, assuming that no federal financing would be available for the rehabilitation. As such, the dam and rehabilitation would be paid for using state funding and would be performed such that the dam would be rehabilitated to meet Georgia Safe Dam's program criteria for a high hazard dam. Another alternative that that is being considered and evaluated is decommissioning of the dam. This involves removal of the earthen embankment, stabilization of the excavated channel and resulting lake bed, and also could require consideration for flood proofing or relocating downstream hazards. As we stated earlier, the dam currently provides a level of flood protection to downstream areas, and removal of the dam will have an impact on the benefits provided by the dam. The final sets of rehabilitation alternatives that we'll discuss today are structural rehabilitation alternatives that meet NRCS criteria for the dams. This could involve embankment improvements such as raising the crest of the dam or flattening the upstream and downstream slopes, the construction of a new principal spillway and the decommissioning of the existing principal spillway that's aging, and some consideration for a new auxiliary spillway, whether it be an earth cut, labyrinth crested, or OG or RCC spillway. The development of NRCS rehabilitation alternatives also includes consideration to ponds upstream of the dams that may not be designed to the same criteria that a flood control dam is designed. And also the alternatives have been developed considering the uncertainties associated with climate change and what rainfall events will look like over the next 50 to 100 years in this area. The first alternative is the no action or federal without project alternative. This is the alternative that would bring the dam into compliance with state criteria. This alternative would involve raising the crest of the dam to provide adequate freeboard during the design storm event, regrading the upstream and downstream slopes to a 3-to-1 slope to improve stability and maintenance of the dam. Also, the construction of a riprap lined wave berm along the upstream slope of the dam, and decommissioning of the existing auxiliary spillway by closing it off and making it part of the new embankment. This alternative would also include the construction of a new principal spillway riser structure, installation of a new principal spillway conduit, and the construction of a riprap lined plunge pool at the downstream end of the conduit. Finally, the auxiliary spillway for this dam would involve a reinforced concrete labyrinth crested chute spillway. The spillway would have a total width of 60 feet and be composed of two 30-foot cycles. The spillway would be constructed over the existing embankment, and we've attempted to give consideration to maintaining access to both sides of the spillway from the dam crest. The spillway would also include a reinforced concrete stilling basin and riprap lined apron to dissipate energy associated with the high flow storm events. The plan view of the Safe Dams program or no action alternative for the dam. You can see that the existing emergency spillway on the right side of the page will be filled in with the embankment fill, extending the crest of the dam to the elevation of the right abutment, and also including flattening of the slopes to 3-to-1. The spillway would be kind of situated so that discharges for the large spillway 2 flow would be conveyed into the floodplain and into the original channel downstream of the dam. The profile view of the labyrinth spillway. You can see that in this particular configuration, we are proposing to build the new pipe and riser along the same alignment of the concrete spillway. The pipe would discharge base flows and any flows related to very frequent storm events into the stilling basin, as indicated here. Regarding the NRCS vegetated auxiliary spillway alternatives, we considered this alternative, but it was determined to be infeasible due to the nature of the modifications required for the vegetated auxiliary spillway to work. Typically, the NRCS requires that the auxiliary spillway be raised, and the materials that were evaluated were relatively erodible, and so while consideration was given to this alternative, it was determined to not be feasible on its own. As part of the planning study, we do have to look at a decommissioning alternative, which would involve reconfiguring the existing structure so that it would no longer be classified as a dam. The process is more involved than simply breaching the dam and would involve removal of most or all of the existing dam, reconnecting the grade of the original floodplain, stabilizing the resulting lake bed with permanent vegetation, and stabilizing the primary channel through the footprint of the old dam with riprap. While decommissioning the structure would improve flooding upstream of the dam, the downstream flood benefits provided by the dam would be lessened. The planning team is evaluating and quantifying the downstream benefits currently provided by the dam, as well as the loss of those benefits were the dam to be removed. Here's a plan view of what it would look like to remove the dam. You can see that we've attempted to reconnect the floodplain based on the original contour before the construction of the dam. As part of this decommissioning, the lake, the portion of the lake that used to have water in it would be exposed. It would need to be stabilized with vegetation and likely returned to a wetland state. And the portion of the original stream channel that runs through the dam, kind of where the existing principal spillway is located, would be lined with riprap. And here are a couple of profile views of what the breach would likely look like through the dam. We've also included some photographs of example dams where the dam has been breached and stabilized. You can see that the embankment would be removed. Any disturbed ground would be grassed. The channel through the dam, at least the main channel where flows would be expected to flow on a regular basis, would be lined with riprap. So the first of the two NRCS structural alternatives that we'll discuss is the labyrinth spillway alternative. As similar to the Safe Dams Program rehabilitation, the existing embankment will be raised to the current maximum water surface elevation associated with the design storm. The upstream and downstream slopes will be flattened to 3:1 or regraded to 3:1. A riprap-lined wave berm would be constructed along the upstream shoreline, and the existing vegetated auxiliary spillway would be decommissioned or closed off with embankment fill. This alternative does include a new principal spillway and plunge pool, and the reinforced concrete labyrinth crested chute spillway would be 136 feet wide to pass the design storm, and it would be composed of 4 cycles of equal width. Consideration has been given to providing access to both sides of the spillway from the dam, and the spillway would include a stilling basin and riprap-lined apron to dissipate energy associated with high-flow storm events. Here's a site plan of the NRCS labyrinth alternative. As you can see, it's larger than the SDP labyrinth because the design storm is larger, and we would have to pass a higher amount of rainfall through this spillway without allowing the dam to overtop. The dam crest is slightly higher as well due to storage requirements, and you can see that the existing principal spillway would be decommissioned and a new principal spillway would be constructed to discharge into the stilling basin for the labyrinth spillway. And here's a profile view of what the NRCS labyrinth spillway alternative would look like for dam number 59. Also included some example photographs of what a labyrinth spillway would look like when it's finished. You can see that the spillway can be built over the embankment. Some of these spillways have pedestrian bridges or bridges that can support small vehicular traffic. Also, you can see that there would be an energy dissipator at the downstream end of the spillway that's composed of riprap, and there would need to be some grading done downstream of that to reconnect the outlet channel to the original creek. Here's another example of a spillway. This spillway includes the principal spillway, similar to what we've proposed for dam number 59, where the new pipe and riser would be configured to work in conjunction with the outlet works of the Labyrinth spillway. The final structural alternative that we'll discuss today is the NRCS RCC spillway. Similar modifications to the embankment and principal spillway as were described for the Labyrinth alternative. Instead of a Labyrinth spillway, this spillway would be constructed of roller compacted concrete in a stepped configuration, and it would have an OG crest, or a rounded crest, to improve the efficiency of flow over that weir. The total width required for this particular spillway configuration is 325 feet. The RCC steps would have a height of 1 foot. The spillway would be constructed over the embankment, similar to the Labyrinth, and would also include a stilling basin and riprap to dissipate the energy. This is a plan view of the RCC alternative that would be necessary to pass the NRCS design storm event. As you can see, it's a wider footprint than the Labyrinth. There would be steps and a stilling basin. We would be able to construct the new principal spillway in a similar configuration, and we would decommission the existing principal spillway during the construction activities for this alternative. Here's a plan view of the RCC spillway. You can see that the crest includes the OG, or a rounded crest, that improves the hydraulic performance of the weir. You can also see the steps on the 3-to-1 slope and sidewalls that would be used to contain the flows were this spillway to engage during a larger storm event. Also included some photographs of example spillways like an RCC spillway. This spillway has a broad crested weir, but you can see that there are opportunities to place fill and grow grass in the outlet channel. Since these spillways do not frequently flow and would flow in excess of events of the 100-year storm and maybe even the 500-year storm, there are a lot of our clients and owners of RCC spillways that prefer to cover up the steps and grow grass for maintenance reasons. Here's another example where the spillway was constructed over the embankment. This one does have an OG crest, and this spillway includes the placement of topsoil and vegetation all the way up to the crest of the dam. Here's a good view of what an OG crested spillway looks like. You can see that the top is slightly rounded to improve the hydraulic performance of this particular weir. And here's one more view of a spillway that includes some consideration for covering the steps with topsoil and vegetation. This one was taken while construction was ongoing and the vegetation hasn't fully established, but over the course of a few months, the vegetation will take and kind of improve the sightliness of these types of spillways. At this time, we are wrapping up this presentation, but we would like to make you aware that we would welcome your participation in this planning study. And the way that you could assist us is by using the link below to access a Google form where your questions and concerns and any comments that you have about the planning study or the alternatives discussed in this presentation could be submitted. The planning team will accumulate and compile the comments and questions received, and will develop responses that will be released to the public at a later date. This particular presentation and Google form will be available to the public through Monday, January the 4th, 2021. So we would recommend sooner rather than later accessing the form and submitting your questions within the allotted time given for this particular study. Once again, on behalf of the planning team, we would like to thank you for your interest in this project. We look forward to any questions and comments you may have regarding Settingdown Creek Dam number 59, and we hope that you have a good day. Thank you very much.